Hello. So I think that you were having trouble with this problem here, constructing the 95% confidence interval for a mean. So I just want to kind of go into why we construct confidence intervals. So first of all, if we want to talk about accuracy in estimation, if I just have a sample of 86 patients and I'm talking about, trying to figure out what the mean incubation period for SARS is, and I'm talking about all of the cases of SARS, the population of the SARS virus, that one sample isn't going to be the best estimation. So therefore what we do is we create this confidence interval, which instead is an interval of values that I say, okay, I am 95% confident that I've captured the true population mean of the incubation period for the SARS virus. So one thing that we have to be mindful of with mean is that if I don't know the population standard deviation, which often we don't, we know the standard deviation of our sample, standard deviation is going to vary very widely from sample to sample. So instead of being able to use our z-score to construct our confidence interval as we had with proportions, we have to use what's called a t-value. So just, so you couldn't find the formula, so I wanted to show you where that was. So I know in the question help here, it didn't have a link to the text, which is kind of annoying. So if I go to the book, where's my book here? Here's your formula for finding your lower bound and your upper bound. So we're going to take that sample mean and we're going to subtract our t alpha over 2 times my standard deviation over the square root of n, and for the upper bound, we'll add that. Now what I really hope is that you're taking advantage of either StatCrunch or Excel. In particular, I like StatCrunch because it does do this for us quite nicely, and then we can focus on what it means, right? So again, I'm trying to, 95% of the time, I'll capture the true population mean for the incubation period for SARS. So let me show you how to use StatCrunch for that. So if I go to my question help, I can click on StatCrunch. And, this was something else that I had done. Oh, maybe I'd done this earlier. I may have done the same problem earlier. So let me show you how to work it. So we're going to go to Stat, and we're going to go to T-Stats. And we're going to do one sample. And in this case, we're not given the data itself. We're given the summary. We know N, we know the X bar, we know S. So we have the summary here. So let's see, my sample mean was 4.4 days. My sample standard deviation was 15.2. And then my sample size is 86. And we want to run a confidence interval for mu, and we want it to be 95% confidence. We can change our level of confidence as we see fit, or as the problem dictates. And I click compute. So here we go. We have that our standard error. Now remember, standard error, if I go back to the text, that would be this value here, right? So this t value times the s over square root of n, that would be our standard error. And it's giving us that there. Sometimes they call it margin of error, right? So that's that value there. And they've actually even calculated the lower limit and upper limit for us. So they've taken the sample mean, subtracted the standard of error for the lower limit, and added our standard of error for the upper limit. Now, if you're looking just to do this by hand, again, it can be really helpful to use StatCrunch to find your t-values. You can also do that in StatCrunch. So if you go to Stat, and I go to Calculators, I can calculate my t-value here. So again, if I want to be 95% confident, that means I want 95% in the middle of two values, right? So I'm going to look for between, and I want the area in between to be 0.95. I can click compute, and it will give me my upper and lower t-values. So you would use this 2.2281 as your t-value, and then do times s over the square root of n, and then add or subtract that from your mean. Okay, I hope that helps, and let me know if you need any more help.